Lesson 5.6, page number 405, equations containing decimals. We're going to do a lot of the same things that we have been doing in past lessons with decimals, only in this particular one we're going to be using our variables x and y as we go through here and do these. So let's start on page 405 and just try a few examples here. Example 1, solve the equation x plus 8.2 equals 5.7. Alright, in the past what we've done with these is we have had a whole number, so let's just forget this for right now. If we had x plus 2 equals 6, we would get rid of that 2. We would isolate the variable. We'd get the x by itself. In order to do that, we subtracted 2 from here and 2 from here. What we did on this side, we also had to do from this side. That got rid of this number, and that gave us x equals 4. It's the same thing, only we have decimals here. So everything works the same. So we take and we try to get rid of the 8.2, so we subtract it from here, and it disappears, and we subtract it from here. And now we have x equals negative 2.5, because we're going to do our traditional, if we have two numbers, positive and a negative, if we add them, that means we take the difference between them because we have different signs, and then we put the sign of the largest one on our answer. And that's all there is to it as far as adding and subtracting. Let's do a division. 3y, which this is example number 2, 2.73. Okay, remember from past, I think it was chapter 3, in order to get rid of this 3, we do the opposite of multiplying it times the y. So we divide it by there, by that y, and we divide it here. So we have 2.73 divided by 3. So 2.73 divided by 3, bring our decimal up like that. 3 goes into 2, it doesn't. 3 goes into 27 9 times. 9 times 3 is 27. We have 0 left over. We bring down our 3. 3 goes into 3 once. 1 times 3 is 3, 0, and we're done with 0.91. So that's the only difficult part, is the 2.73 divided by 3 that we have to do. Alright, so continue on looking at some of these examples. At example 3, we have 1/2 x minus 3.78, and that equals 2.52. Alright, so now we're going to do our PEMDAS again, or, well, I guess not really PEMDAS. It was a step that I gave you, or a clue that I gave you, or tip. When you're trying to isolate the variable, you get rid of all the numbers added or subtracted to the variable first, and then you worry about numbers multiplied or divided by that variable. So let's get rid of the number subtracted from it first by adding it to both sides. Nice thing about stacking them in columns is you can actually go ahead and do the addition right here and not have to rewrite it somewhere else. So it's going to be 10, carry the 1, 13, carry the 1, 6.3. Now I've got a 1/2 in front of my x. So again, remember on the last problem we had a 3 in front of the y. We divided both sides by 3. Well, here we're going to divide both sides by 1/2. And whenever we divide by a fraction, the bottom number, we flip upside down and multiply it. We take the reciprocal. We multiply by the reciprocal, 2 over 1, or just 2. So 6.3 times 2 is 12.6, and that ends up being our answer then. So that's example 3. Example 4 just again goes into some of the other processes or possibilities that we've had before. You've done all of this, but it doesn't hurt to review it. So let's go ahead and put it up here. That's a minus sign here. Equals negative 3a plus 0.98. Notice how I put a 0 in front of the decimal here. It's just the common way of doing it. Just like you reduce a fraction, you put a 0 here rather than just a 0.42, because oftentimes you look at that decimal on your paper and it looks like a pencil smudge, or something along that line, some dead bug, whatever is there, and you forget that it's a decimal. But if you put the 0 in front of it, it reminds you that this little point here is a decimal point, not a smudge or a bug or something like that. So anyway, that's the purpose for doing that. So again, now we've got a variable on either side of the equal sign. So if you remember, we're moving things around to get our variables together and our numbers together. It doesn't really matter what order we do those in, since we just have two terms here with a subtraction and two terms here with an addition. So there's no multiplication or division of terms, so that makes it easier, or multiplication or division that we would have to do first. So let's just, because we have this over here, let's move it over here. So we're going to add 0.42 to both sides. And so this is going to stay negative 3a, but it's going to be plus 10, carry the 1, 14, carry the 1, 1.4. And that's going to equal 5a. Okay, now we've got a negative 3a. Let's move it over here. So remember, we add 3a to both sides. That gives me 8a. Those disappear. 1.4. Now, to get rid of this a, 8, we divide both sides by 8. Gets rid of that. So 8 equals 1.4 divided by 8, which ends up giving us 0.1. That doesn't look like a 1. 0.175 for our answer. And that takes us to the next page, chapter 406, as we continue with lesson 5.5. Alright. Applications. Applications, I know, are your favorites, where you get to actually use this stuff. A car rental company charges $11 per day and 16 cents per mile for their cars. Still got some water up here. Okay, and then 16 cents a mile. 16 cents is actually written 0.16 per mile. If the car was rented for 1 day and the charge was $25.40, that's the total. Okay, if it costs a total amount of $25.40, how many miles was it driven? Well, regardless of how many miles I drive, and I'm paying $11 a day. So out of that $25.40, $11 of that is coming off the top. So that means that I actually paid $14.40 for the mileage. So if I take $14.40 and I divide that by how many miles it was, or how many cents it was per mile, I'll find out how many total miles I drove. And in this case, we end up with 90 miles. So we're not doing anything really difficult as much as we are trying to take the information you've learned as far as doing decimals and putting them into practice. Same thing with example 6. So example 6 says Diane has $1.60 in dimes. And I won't get done with this whole thing in the time we have in dimes and nickels. So we'll shut this video off in a minute here and do a 5.6b. But anyway, she's got $1.60 in dimes and nickels. So if we take the number of dimes she has times how much a dime is worth, and we add the number of nickels she has times how much a nickel is worth, we will get $1.60. Does that make sense? If we have 3 dimes, it's worth 30 cents, because 3 times the 0.1, or the 10 cents that it's worth, is 30. And if we have 4 nickels times they're worth a nickel, so we've got 20 cents, and we add up these two numbers, we get the total value. Alright, so I'm going to turn the video off, and in just a second we will go back to this problem again and continue on with it.